you guys spent half the class making sure you understood how to essentially make the rectangles. All right, and then there was one little one that was different where I asked you to make trapezoids. So today, we're actually going to calculate those approximations. All right, so going a step farther, where we're going to actually be given a table of values and actually come up with a number for the area under the curve. Okay, so we're going to start as basic as I can with the right Riemann sum. You'll notice on this paper there are three we're going to do together. We're going to do a right Riemann sum, a midpoint sum, and then a trapezoidal one. Which one have I left out? The left. And so make sure before we finish the right, I'll show you how it would be different if it had said left Riemann sum. All right, but those are hopefully the most basic. What I would tell students always when you see your right Riemann sum or left Riemann sum is to write down your intervals. So my first interval in my x values is 0 to 4. My second one is from 4 to 6. My third one is from 6 to 10. And my last one is from 10 to 12. Now, when you're doing problems for this link, what you might notice that's different today than from yesterday is the width of these intervals are not the same, right? So this one has 4, there's 2, there's 4, there's 2. So you're going to have different width of your intervals. So be okay with that, okay? So to find the approximation for a right Riemann sum, I'm going to find the area of each of these rectangles, all right, using that formula. Okay, so the idea is if we're using length times width, the first thing I usually write down is I write down the width. Okay, so what is the width of my 0 to 4 interval? 4. Okay, so that is our width. Now the length is actually going to be, if you were to look at the graph of this, it's going to be going up vertically towards the function. All right, and because we're doing a right Riemann sum, what is my right number in this interval 0 to 4? The 4, so I'm going to write down f of 4. Now, some of you already realize what's going to happen, right? What is f of 4? It's 6. So if you want to skip that step when you're doing them, feel free to. I'm trying to show you all of the steps. So that's one rectangle. Everybody good with the first rectangle? Yes. Yes, so the idea is, if I were to sketch it, maybe that'll help. All right, so this first one is 0, 16, and 4, 6. Okay, if I make a right Riemann sum for the area under that part of the curve, right, you should see that my width is, right, this is 0 to 4, so that's 4. And then how high is it going up? Right, it's going up this height, which is going to be f of 4. All right, so that's only because it said right Riemann sum. If it had said left Riemann sum, I would be doing f of 0, right, of the left one. So what I do is my brain thinking, I'm using the right numbers. Everyone okay? Yes, Alan.
Could that also be on the second quartile? Like, could you flip it and also have it on the negative?
Oh, could we move into negative? Absolutely, yes, for sure. We're going to get there. We're starting very slow. All right, plus. Let's do the next interval. The next interval is 4 to 6. What is the distance between 4 and 6? 2. So that's going to be my width. All right, and then I put an arrow next to which of these numbers is on the right? The 6. So I'm going to do f of 6. Why don't I do this? I'll keep going to set it up, and then we'll do the next line. Plus, remember to stop me if you have a question. Eduardo and Alan have already asked questions, right? That's great. Keep asking those questions. The next interval is 6 to 10. What is that distance between 6 and 10? That's 4. Remember, I'm using my right Riemann sum, so my right number is 10. So that length is going to be f evaluated at 10. The last one. What's the interval distance for 10 to 12? That's 2. The number on the right is 12, so I'll be doing f of 12. So the only thing that would be different if this was a left Riemann sum is that this would say f of 0, f of 4, f of 6, and f of 10. That's the only difference. Anita.
Each one will have its own. It will be like.
You mean like in terms of these values?
Yeah.
No, they will not repeat. That's a good question. Yeah, you should not have a repeat. Yeah. Are you guys ready for me to use the table to evaluate? Okay, so f of 6 is 7. F of 10 is 16. F of 12 is 18. If you want to use a calculator, you can. I'm not stressed about it. It's more about the setup. This is 24 plus 14. 16 times 4? 64. 18 times 2? 36 is right. One more time. Oh, you already did it? Wow, I was going to show you. What's 64 plus 36? 100. That's nice. 24 plus 14 is 38. So 100 plus 38 is 138. So that is our approximation for this integral using a right Riemann sum.
It doesn't have units, right?
Don't need to write any units. I mean, technically it is area under the curve, so if you want to write square units, you could. Any questions on number 1? Okay.
You don't have to.
No, you don't have to. You just type in Delta, just type 138, enter. You're good. Okay. Do I need to explain how it would be left Riemann sum, or can I move to the next one? Okay, I'm going to move up. Number 2. So number 2 is going to be the midpoint. All right, so this time I'm going to write down my intervals again. Okay, I'm going to write down my intervals again, but you're going to notice that the table is going to give you more stuff because we need the midpoint value. So here's my first interval is 4 to 6. Notice what number did I skip? 5, because that is the value I'm using for the midpoint of that interval. Okay, so the next one is going to be 6 to 8. Notice I skipped 7. Then 8 to 10, skipping 9. Then finally 10 to 12, skipping 11. So this one's going to be a little tricky because when I set it all up, I'm not going to be using f of 4, f of 6, or f of 6. I'm using neither of these. I'm using f of the number that's in between them. What's the number in between 4 and 6? 5. So I'll be doing f of 5. So that's the difference here. So this is the midpoint. All right. I always do the first one. What is that interval distance between 4 and 6? 2. And as a quick little note here, what do you notice about all of the intervals? They're all 2. So this one, they are the same. Okay. So sometimes they will be the same. But I'm writing down f of 5. And if it helps your brain, right, 5 is the midpoint. Okay, so I'll be using 5, 7, 9, and 11. Plus, we said all of these distances are 2, and I'm doing f of 7, plus another 2, f of 9, and the last one is f of 11. Remember to raise your hand and ask if you are confused. Okay, let's use the table. F of 5 is 4. F of 7 is 19. F of 9 is 21. And F of 11 is 34. You already got the answer, Bernadette? Wow. Message. All right, so 8, 38, 42, and what is that? 68. Oh, you did this one? My brain went to that one first. Nice. So you did 68 and 42. That's going to be 110. 110 plus 46 is 156.
Yeah.
Any questions on the setup for the midpoint? We're about to enter the last one, which is the hardest one. the trapezoid. This is the one I love, right? I love when I see a trapezoid. Yeah.
So, for this one, right, when you do that, it will be the same in the F focus, the left.
You talking about number one? Yeah. So the only difference if they change this word to left would be instead of, see where I wrote f of 4, f of 6, f of 10, f of 12, right? Because those are the right numbers. I would have used f of 0, f of 4, f of 6, f of 10. So those are the left endpoint numbers. Okay, that's the only difference. Everything else would be, obviously the numbers would be different, but like that's the setup. All right, the last one, number 3. I put the whole page for this one, so I'm going to do a quick little sketch to make sure we understand. This one's going to be a little tougher. All right, so again, just a sketch, doesn't need to be perfect here. I've got 3, 13, 5, 8, 6, 7, 7, 8, 8, 9, and then 9, 12. Something like this. All right, so we're trying to find the area under the curve for this portion of this function. All right, now this first one is the only one that has a width, even though I'm going to change that to height here in a moment, right? Going from 3 to 5, what is that distance? That's 2. So this one is going to have a 2 here. All the other ones, right, 5 to 6, 6 to 7, 7 to 8, 8 to 9, are all 1s. All right, so they're going to be a little closer together. Yeah, I'll show you right now. So I'm going to make the first trapezoid, okay?
Oh, are they sideways?
They sideways. I'm not sure. I'm about to make the trapezoids like this.
No, they're sideways.
Yes, they're trapezoids on their side. Sure. Okay, let's start. Can we start with that first blue trapezoid? Let me zoom in. You guys ready to start with this one, first one? Okay. So what I was trying to say, and maybe this will help, putting numbers will be helpful, is the first one, is it 3 and 5?
Yes.
So what is that distance?
2.
That's 2, right? So before, when we did rectangles for right or left or midpoint, I told you to use that as the width. But for the trapezoid, because they are on their sides, I'm going to say that's the height. All right, so my height is going to be 2. Do you see these side lengths? Those are going to be my bases. All right, that's going to be, you can say base 1, base 2, whatever you want, doesn't matter. Right, so these two are going to be my bases. All right, and those distances match up to the values for those particular ones in the table. So I'm going to go to the table in a moment and do what is f of 3 and what is f of 5. So what is f of 3? 13. And what is f of 5? Is 8. Right? So remember, this is, I know it's weird to say, but this is base 1, and this is base 2. And there's my height. So now I have everything I need to find the area of that blue trapezoid, just that one trapezoid. Okay? Let's write down the formula for the area of a trapezoid. It's 1/2 times the sum of the bases times the height. Now I'm going to write it a little bit differently when I do my work. I think it's a little bit easier to kind of like organize it. I'm going to rewrite this as the sum of the bases divided by 2 times the height. But it doesn't matter. That's the same thing. Okay, so can I write the first one for you? All right, so here's the first one. This is going to be trapezoidal. All right. I'm going to write down, do you guys want that extra step where I put like F of the numbers? Julie's like, stop. All right, I'm going to do it, but you don't have to. Julie, to be honest, I don't anymore, right? At this point, I just do the values. So I'm going to write down F of 3 plus F of 5 over 2 times, and what did we say the height was for that first blue trapezoid? Times 2. And we will just cross them out here in a moment. You're right. Okay? You guys okay with that setup so far? As I said, I'm going to be replacing F of 3 with 13 and F of 5 with 8 on my next step. So I'm going to do this setup for the rest of these Blue, you guys okay if I do the same color? I try my best for this one where I think we can do it mentally, but if you'd like to use a calculator going forward, that's fine. Just know that like on the AP exam, you won't get a calculator for these types of questions. But that's not what I'm worried about right now, Gail. I'm worried about the setup. Okay, ready for the next one? All right, so the next one, isn't it 6, 7, 8, 9, right? It's just 1 each time, right? So all of those are going to be 1 now. So I'm going to have f of 5 plus f of 6 over 2 times 1. What I also would recommend doing, because I know it can be a lot, is what I would do when I was in high school is I would count how many trapezoids. How many trapezoids? There's 5. So how many of these should I have? Should have 5, right? So just be aware of that. Hopefully that matches for you. Plus f of 6 plus f of 7 over 2 times 1. If you run out of room, I've run out of room. I'm going to keep going because I can, but like you don't have infinite space. If you run out of room, just go to the next line. Totally fine. Plus f of 7 plus f of 8 over 2 times 1. Just go to the next line. Nice, you already did it. Well done, Evan. Plus f of 8. It is a pattern here. All right, so that's all of it. And it's pretty small to see there. I'll zoom in once I get all the values. Everybody okay with the setup? You probably start to see the pattern. One student last year was like, each time you finish one, that's going to start the next one. You always think of that too. Okay. All right, so let's write down the table values. This one was 13 plus 8. F of 5 is 8. What is f of 6? Is it 7? Okay. What is f of 7? 8. What is f of 8? And then what is f of 9? 12. All right. Bernadette already noticed that if you have your height of your trapezoid is the same as this number at the bottom, those will cross out. So 13 plus 8 is going to be 21 plus. All right, so here you go, Gael. This is how I would do it like without a calculator. 8 plus 7 is 15. What's 15 divided by 2 as a decimal? 7.5 plus, you'll notice this is actually the same thing. The numbers are obviously just reversed, right? But 7 plus 8 is still 15. 15 divided by 2 is 7.5. 8 plus 9 is 17. 17 divided by 2 is 8.5. And the last one is 21 divided by 2, which is 10.5. You can also do it like this. These are 0.5. There's 4 of them, so that's actually 2. Right? If you take 4 halves, that's 2. What's 7 plus 7? 14. 14 plus 18? 14 plus 18? 30. 32. 32 plus that 2 is now 34. What's 34 plus 21? 55. Again, not concerned if that's an issue mentally. Okay, I think the hardest one is the trapezoid, right? That requires, I think, the most work and the most setup. Any questions on the trapezoidal sum? What I will say before I hit done here is that it is the most work, the most time consuming, but it's also the most accurate for the approximation. So it is, in terms of these options, it is the best. Go ahead, Edwin.